Hello everyone. The goal of this presentation is to give an overview of Ipmx in order for you to understand the technology we are proposing with this initiative. Let me start by giving a little background on Aims, the organization promoting Ipmx. The Alliance for IP Media Solution is a non-profit trade organization open to everyone, founded by leading companies in order to work towards one common goal. That goal being to foster the adoption of one set of common, ubiquitous, standard-based protocols for interoperability over IP in the media, entertainment, and professional AV industries. Aims members believe strongly that the future of AV over IP should be built on a technology infrastructure that is based on open standards, namely Ipmx, the IP media experience. As seen on this slide, we are an organization of about 100 members, comprised of both users and vendors. In the recent years, Aims has gained widespread industry support in broadcast and now Pro AV for that goal mentioned earlier, the adoption of open standards in the transition to IP infrastructures. Where does Aims stand in the grand scheme of things in the adoption of Ipmx? The effort starts at associations like VSF and NMOS that through meetings and discussions, the participating companies are putting together a technical recommendation that represents the basis of the standards. The technical recommendations are then taken to organizations such as SMPTE, EBU, and AES for them to turn those recommendations into well-defined standards. Those standards are grouped together in a reference architecture published by the JTNM group, which also ensures interoperability by organizing test program events where vendors are given the opportunity to evaluate the interoperability of their products with others. The results of such events are openly published in a test program catalog available on the JTNM website. Aims' goal is to promote the adoption of this suite of open standards throughout the industry using various means, like press releases, webinars, trade show events, and recruitment, making sure the actors of the industry, people like yourselves, are fully aware of this ongoing effort and trying to bring you on board by joining the Alliance. What do we imply exactly by open standard? Well, in any technology shift, it is quite natural that multiple implementations of a technology are put forth to the industry for standardization. And in particular, early adopters and technology suppliers in their drive to lead often seek to standardize initial proprietary approaches. Well, us at Aims believe that if we, as an industry, do not adopt a common view of standardization for IP, we simply risk fragmentation and interoperability nightmares for years to come. If this happens, everyone loses, as implementation costs for both end users and suppliers will increase. Right now, the Pro AV industry is up against the same issue that the broadcast industry faced about 4 years ago: the inevitability of a transition to IP infrastructures and a decision as to whether to buckle under pressure to adopt closed proprietary technologies or unite behind an open standards approach. Aims strongly believes that for the industry to thrive, a single standardized interface for IP is simply logical and essential. The rationale for common standards is obvious. Interoperable solutions based on widely accepted open standards have driven many industries' growth and success for decades by accommodating its actors' current needs and ensuring they are prepared for future advancements. Open standards provides the ability to add new capabilities and services without having to constantly rebuild their workflows, while having the freedom to build best-of-breed networks. What exactly is meant by AV over IP? Well, pretty much every aspect of moving streams through an IP network, starting with transport of the streams, audio, video, and various metadata, how the synchronization is maintained between those media types, the latency requirements, and also all steps required for proper stream management: registration, discovery, subscription, control and routing, while supporting many use cases like point-to-point configuration, or one source streaming many endpoints, for example. The backbone of the Ipmx solution is comprised of two sets of specifications, namely ST2110, which covers the transport of the stream, and NMOS API suite, which cover the management. ST2110 is a composable standard that solves problems in layers. It includes many standards that make up the whole, making the addition of new ones needed to address specific needs very easily, and in this particular case, targeting the Pro AV industry requirements. The NMOS layer handles the network management aspects, how the devices are registered and discovered on the network, how they are subscribed and controlled, amongst other things, providing an API to perform all of those. For the next few slides, I will focus a bit more on the ST2110 principles. Let me first describe the two fundamental approaches to IP transport. The bundle approach is grouping the media types together within the same IP stream. This gives the advantage of making the types automatically synchronized together. However, it forces you to unpack the types in order to treat them. The essence-based approach is decoupling the media types by transmitting them in separate IP streams. This gives the ability to only receiving the desired media type. For example, if you're only interested in getting the audio types on a particular endpoint in your infrastructure, you are not required to receive the video, for instance, which would greatly increase your bandwidth requirement for no particular reason. However, there is now the need for a mechanism to synchronize your essences. ST2110 uses the essence-based approach, and each of the essence is covered by its own ratified specification. So the transport of active video packets is described in the -20 version of the spec. The audio channels is described in the -30, and the transport of ancillary data is described in the -40 specification. In fact, there's a whole suite of standards to cover many aspects of AV over IP. I want to go over quickly the ST2110 standard suite to give you an idea and show you that the suite is addressing the protocol in layers, making it very easy and convenient to build on it, adding new requirements to target particular aspects or needs, like the one we need for Pro AV market, for example. The -10 is covering the system as a whole, describing the timing model and common requirements across all essence types. The -20 is, as I said, is covering the transport of uncompressed video. -30 for the PCM audio transport. -40 is there to describe the transport of ancillary data. The -21 is specifying the traffic shaping model for the senders, basically requiring those senders to be network friendly. You do not want your senders to burst all of their data at once, which would basically overload receivers and network switch buffers. The -31 is covering the transport of compressed audio. The next two are the most recent and probably the most targeted to the Pro AV industry. The -22 is used to transport compressed video. Ipmx is promoting JPEG XS as a codec, but any codec has the potential of being used as long as they are open and they have a available RTP profile. The -41 documents a payload agnostic method for carriage of various metadata, and it is considered in the possible options for Ipmx. It could be used for HDMI data island carriage, for example, but this is still all under discussions at this point. As described earlier, ST2110 is essence-based, which means that each media types are transported on independent streams. This imposes a need for a synchronization method between those streams. The method used is Precision Time Protocol, or PTP, which is a proven technology already used in multiple industries. Defined by IEEE 1588, it is a very precise method for distributing timestamps over an IP network for synchronization and alignment of signals. The alignment requirements and specific profiles are covered by ST 2059-1 and -2. Later in the presentation, I will cover another alignment method proposed for Ipmx. Here you're seeing the Aims roadmap as published October of last year. In September 2017, the first set of SMPTE ST 2110 standards were published, launching officially this open standard. The latest addition was the adoption of TR 1001, which is a technical recommendation published by JTNM that go over the system environment and device behaviors. It is listing the required network services and protocols that should be supported in order to enable the creation of a network environments where an end user can take delivery of new equipment, obviously compliant to this recommendation, connect it to the network and configure it with the minimum amount of human interaction. In other words, it states the guidelines to vendors in order to ensure smooth interoperability. Momentum has never been stronger to migrate to AV signals transport over IP networks. So the promised benefits, greater interoperability and flexibility, are coming to fruition for the adopters all over the world. As seen here, the basis of the suite is well in place. The next step is to adapt the suite for Pro AV particular needs. This brings me to the next slide, the Ipmx draft roadmap proposal. AV over IP is already transforming the Pro AV world just as it has done for the broadcast industry. There's work to be done though, and that's where the Alliance for IP Media Solution comes in. AIM's mission is to foster the adoption of one set of common, ubiquitous, standard-based protocols for interoperability over IP in the media, entertainment, and yes, Pro AV industries. In December 2018, AIMS launched a Pro AV working group tasked with promoting a set of media over IP protocols for the professional AV and installed system markets. The idea is to leverage the work already accomplished and build on it by incorporating features specific to the Pro AV market. These includes security, HDCP support for protected content, compressed video, and I/O expansion and control. The Ipmx draft roadmap proposal reflects the work of the JTNM, providing clear guidance on those standards and specifications, which provides the foundation for system-level interoperability. Products developed in compliance with the Ipmx roadmap will then meet the necessary requirements for complete interoperability. As you see, definition and adoption of standards of prime importance for Pro AV market are currently in progress. Now is the perfect time to join the Alliance if you want to influence the definition of those standards. The next portion is going to cover few aspects of the work that is being done right now for Ipmx. Ipmx requires sender to abide by the alignment point as defined in ST 2059-1, but also provides an alternate mechanism to solve two issues that are the dominant use case in the Pro AV industry. One, the asynchronous media support, and two, a very low latency for such media. As opposed to sync media, the async media provides a mechanism that allows async media receivers to recover the timing from the sender using the RTP timestamp, and also providing an optional fast locking mode through the RTP header extension. Another topic covered is how the playout time is aligned. This is achieved using a couple of parameters which permits to set the playout time precisely in order to accurately synchronize all receivers. Those parameters shown in the diagrams here, namely TR offset and RX offset, are used to take into account internal delays of individual devices. The first diagram, the one in the top right corner, is showing the relation of RX offset with respect to the sender timing. By programming multiple RX devices with corresponding RX offset, we can align them very accurately. The second diagram is showing that by using the same RX offset parameter, you are able to achieve very low latency if your infrastructure permits it. Content protection is of prime importance in Pro AV. This is why Ipmx is enabling the support of HDCP in the current transport stream. The current proposal is derived from the HDCP interface independent adaptation specification. The actual specification is based on MPEG-2 TS protocol, so the idea is to adapt it to incorporate the RTP packet protection. If you are familiar with the specification, you will recognize this diagram. It is pretty much unchanged, as the intent is not to change the fundamental of how the content is protected. The same cipher structure is used, the same key and counter handling is used. We are adapting the wording to relate to RTP streams and addressing few particularities. Basically, how the counter are propagated within the streams now. Evolving within an IP network, we have to reduce the impact of packet loss. We certainly do not want to corrupt a whole frame in this eventuality. The current proposition we are working on is the use of the RTP header extension to convey the counters and therefore being able to decrypt each packet independently. To ensure complete interoperability between Ipmx devices, a HDCP key exchange protocol is developed as well. Like the transport aspect, the key exchange protocol is based on the DCP LLC specification, HDCP Interface Independent Adaptation Specification, version 2.3. The key exchange protocol defines the behavior of the NMOS Ipmx nodes and states operational guidelines on the use of the HDCP standard to maintain the node's interoperability. The HDCP protocol messages are exchanged through a TCP/IP out-of-band channel, and the HDCP encrypted data is being transmitted as per Ipmx through a RTP stream as described in the previous slides. Both channels taken together behave as per the HDCP interface independent specification. The objective of the specification is to define a mechanism to allow devices implementing HDCP protection to exchange keys and messages. It is common knowledge that networks cannot be considered 100% reliable. Broadcast ST2110 network addresses the reliability problems with 2022-7, which is full network redundancy, basically receiving the same stream twice, usually on separate networks. Even though this is a pretty robust method, it comes at a high price. To give more flexibility and options, Ipmx, while supporting 2022-7, is also defining a FEC, Forward Error Correction scheme, which provides robustness without too much overhead. We are currently working on a dual parity scheme, which involve a row and a diagonal FEC. Like I said, they will be optional and they could be enabled separately. The amount of data packets covered per FEC packet is intended to be programmable, therefore adjustable based on your environment. Obviously, the more FEC packet you have, the more overhead it represents, but the more resilient you might be. The goal is to keep the overhead below 10%, but like I said, we want it to be controllable. Also, the algorithm used is permitting us to generate the FEC packets on the fly, giving us the ability to keep the latency to a minimum. Ipmx provides virtually no resolution limit, as this aspect was thought through at the definition of the standard, making sure we will not hit a roadblock due to technology advancements. It also gives the ability to evolve in IP networks ranging from 1 gigabit to 100 gigabit and beyond. Again, there's no limit on this aspect. It also provides a solid compression solution to permit UHD resolutions in networks of speed as low as 1 gigabit. ST2110-22 protocol is used to transport compressed video. And as of now, Ipmx is endorsing JPEG XS codec as it meets the required quality and latency and is also very efficient in terms of implementation. But there is place for any codec as long as it is open and as its RTP profile. Aims is calling all companies in our industry to adopt the proposed roadmap, but also to participate in its refinement by joining the work and bringing your ideas to the table. In conclusion, the message we want to get through is that if you believe that a true open standard approach is the right approach, then join the Aims effort. Thank you very much.